Okay, you guys, so one last groundwork item that we need to cover for section 1.2 deals with this concept of similar triangles. So basically what happens here, we have at least two triangles to compare. So that's the first thing. Maybe we have more, but we definitely have at least two. And what happens when we're comparing these two triangles, what makes them similar is there's two facts that have to be happening. And let me go ahead and use the word corresponding. So the first thing is that the corresponding sides are proportional, right? So again, there's three sides to a triangle, and in order for two triangles to be similar, one of the first conditions that has to be met is that the corresponding sides are proportional. And then the second thing that has to be happening is that the corresponding angles are equal. So in a triangle, there's three angles, hence the name triangle. So in a similar triangle situation, the corresponding angles are equal, right? And what makes them truly similar is that the corresponding sides are basically going to be proportional. So let me go ahead and give kind of an obvious picture. What's going to happen here is, let's start with maybe a right triangle. Okay, so there's my right triangle there. And here's something similar to it. So notice the triangle is a little bit bigger, all right? But again, if my drawing is right, all right, what we have, right, are similar triangles. So obviously the 90-degree angles match up, all right? Let's call that theta, so that would also be theta. So the corresponding angles are the same. And let's just call that angle beta and that angle beta, all right? And so basically, again, for two triangles to be similar, right, the first thing that has to happen, or one of the things that has to happen, is that the corresponding angles are equal. So that right angle corresponds with that one, they're the same. That angle corresponds with that one, they're the same. And that angle beta corresponds with that angle beta, they're the same. Right? So far, so good. And then to truly be corresponding, how about I call this lowercase b, lowercase a, lowercase c, and then this uppercase b, uppercase a, and uppercase c, right? And so because this triangle is a little bit bigger, these sides are actually going to be larger than these sides, right? So obviously capital C is not equal to lowercase c, capital B is not equal to lowercase b, and etc. So a similar triangle is not saying that two triangles are the same. It's just saying that the corresponding sides are, the corresponding angles are the same, but the sides are proportional, all right? So that means if we're talking about a proportional, we're talking about fraction. So what that means is basically this, that if I form the fraction a and b, right, if I compare side a and b to this guy, right, that would be similar or equal to, equivalent to side little a, side little b over here, right? And so that's what I mean by proportional. We're setting up one fraction in one situation is equal to a fraction in the other. So you got to make sure that the corresponding sides, notice the way I set this up, right? Side A and side capital A and side lowercase a happen to be the sides that are opposite the angle theta. So they're technically corresponding sides, right? And so capital B and lowercase b also happen to be the opposite side of, if you would, the angle beta. And so they're corresponding sides. So when I form the ratio of A and B, capital, right, that would be the same or equivalent to lowercase a over lowercase b. Of course, because we could deal with fractions, you could also say it that way as well. Of course, your fraction values will change, but the equality, the proportion, will not. And of course, there's a lot of proportions here, right? So there's one set of proportions. We could also say that capital A to C is the same as lowercase a to c, or we can reverse that, right? So there would be another set of proportionalities there. So this capital A related to that capital C, right, and that fraction is related to the fraction a over c. And of course, then we also have the reciprocal. And so another batch would be to say something like capital B is to C, right? So capital B to C, well, corresponding side, that would be lowercase b to c. And of course, we could also reverse that, right? Or what we famously call the reciprocal, right? And I think if we thought about it, That's about it. All right, so there's actually six different proportionalities that we can create from the corresponding sides. And of course, what makes triangles similar is the fact that these ratios will always be the same, right? The corresponding angles are proportional, right? And then the corresponding angles are equal. If I have those two conditions met, we are dealing with a similar triangle situation. And of course, that's some pretty big news to us, especially when it comes to trigonometry. As a matter of fact, for those who might be in the know and take a trig class, you are actually looking at the definitions right here of all our 6 trig functions in some way or another. But more on that as we move forward in chapter 1, and learn a little bit more. But there's your breakdown of similar triangles. I think I've done all the groundwork, ready to go take all these definitions and start doing some homework problems, right, and applying these to certain situations. So I'll see you in the next round of videos in the module.